Hi, everyone. Thanks for tuning in. Today, we will talk about mining and how IoT is helping bringing value in this domain that is digitally transforming drastically. And for that, we have Simon from LithologIQ. Hey, Simon, how are you?
I'm pretty good. Thank you, Oliver, for the invitation.
So, I am Olivier from Axceta. We do IoT, we do integration of IoT into mining, agriculture, and energy. That's my introduction. What about you, Simon?
Yeah, I'm coming from the engineering side of things. So I've been designing hyperspectral imaging devices for about, well, mostly 16 years. So that's a technology we use in LithologIQ solution. So it is hyperspectral imaging devices from the visible up to the infrared. So that is my expertise to build those systems and make them industrial.
So tell us a bit about mining today. So people watching the video, they might be in the mining world, so they will understand really rapidly, the importance and the value add of your solution. But for those who are more on, other domains of IoT, they might be interested about how does mining, especially, the type of exploration we will be talking about today, works today.
Yeah, absolutely. I will skip the prospection part. This really early stage exploration, and it's a little bit out of the scope of the discussion today. So I will start from exploration. So exploration begins with drilling cores. So we will extract thousands and thousands of meters of drill cores from the underground to understand geology. So those cores are actually bring to the core shack for further analysis. So the way it works actually is that geologists and technical people will lay out the cores on table and try to identify minerals, make measurements with basic instrumentation, right? But measuring tapes and rules and stuff like that to get as much data possible from those core because that's the that's the information they use for decision making for further operation. So
Got it.
exploration is drilling, observation, modeling, and decision making.
Mining. So you're basically drilling like cores that will be the actual, layers underground, and then people will analyze. And I'm actually saying people
Yeah.
will analyze
Yeah.
what's going on down there, the type of minerals, the type of whatever is down there, to decide whether or not it's worth going further in this direction, in another one, in that depth, to extract whatever material, minerals you're looking for, right?
Yeah, that's exactly what it is. And the problem is that most of these layers are just invisible to the naked eye. So we're trying to get as much information as we can, but with basic tools, measuring tapes and the eye. But rocks, it can be gray for a long, long time. It can be very gray for thousands of meters of core. So it's really difficult, not because of the lack of expertise of geologists. It's really not about that. It's really about the limitation of the human eye. Well,
Got
we're
it.
just humans. We can see red, green, blue. But what is diagnostics to properly identify minerals? It's really happening in the infrared spectrum. So it's just invisible
Got
to
it.
our eyes.
Got it. We're still pretty good, I would say, because we have chemistry, we have like some level of science that will allow you to analyze the
Mhm.
various minerals in the cores, but that means you have to send the actual cores to a lab and to have chemists and other people do the science on the rocks in order to determine which minerals there are there, but it can take some time, right? So if you have to go to, let's say, the lab version of it, how long would it take for a core to be analyzed and for a decision to be made in order to decide where to drill and how deep and so on?
Yes, and the next step after getting the cores to the core shack, we just slice the core in two parts. We
Mhm.
send one half of the core, we bag it, and we label and we send over truck. And it takes weeks and months for the lab assays to process and to give the results. So in the meantime, what's happening is either the drill is waiting for the results to know, do we continue drilling here? Do we move to the next pad? And we know it will never happen because of those expensive machinery will not stay there waiting for an answer they have to produce. They have to drill because it's expensive to have a machinery waiting. So
Mhm.
either we wait months, weeks or months to get the results, or we go to the next pad. So if that target was good and we move to the next pad, we will have to bring the machinery back a few months later to continue drilling. So we lose money here. But if the current target was bad and we continue drilling because we don't have the info on hand on time, we lose money again. So it's really important to solve this time to decision problem, cutting the loop of decision making to have it in, well, 24 hours is mostly the target to
Yeah.
have on time insights to make that decision.
Got it. So you already hinted at how you're approaching that problem, trying to keep the course on site and to do analytics as much as possible on site and at least in a very fast way, leveraging not human eyes, but specific equipment. So tell me about the LithologIQ solution to solve this problem.
Our solution is just a tool we give to the geologists. It's another tool they have. So it's a scanner we bring on site. It's shaped as a mobile trailer to be right at the core shack. So that's an automated scanner made full of different cameras taking a lot of pictures from the core in the visible, infrared, and all spectrum to get as much as possible information. And it's all about mineralogy. That's mineralogy we extract from the core. And the key point of this solution is to bring quick on-site information in 24 hours for a large volume of drill cores. Because operations, it's daily bringing new fresh cores from drilling activities. So we want to process those cores as fast as possible and give the results quickly to the geologists so they can make the decision. So we're not replacing geologists, we're just giving them some additional data, some more insights so they can make the decision.
You just say something interesting. Previously, you talked about weeks or months
Mhm.
to get that information. Now you're talking about 24 hours, like overnight, basically, right?
Yes.
Dramatic, actually, in terms of improvement of the process. And this is basically a new tool. You're saying geologists are still needed more than ever, and but they can be way more efficient actually because they have this tool. So tell me a bit more about how do you get to that, one day versus weeks. So there are the cameras first. What is particular about these sensors that are able to do things that human eye cannot?
Well, we bundled a pack of hyperspectral imaging device specifically designed for this application with proper lighting. So everything is really super efficient. We
Mhm.
have to take images, a lot of images, really, really fast and in a continuous streamline of operation. So we made that trailer with a conveyor, flow in and flow out, core sample. So it's really fit into a workflow of operation. So you can imagine dropping a core box at the entry of the scanner. It gets out in 1 minute later. So we can scan 2,000 meters per day. So that's the first key to be, well, on time with data delivery is to acquire results very fastly, and to use edge computer for on-site data processing.
Okay, so I imagine just like I've seen some picture, big racks of all the cores lined up, and you have all these notes to remember which one's coming from where, right? Because at some point you have to remember. You're talking about 2,000 meters per day of cores, so that's a lot of boxes. So they're going through that machine. Like lots of data is captured, a lot of data, right? And you're talking about edge compute. But edge compute will do a certain amount of compute locally,
Mhm.
but we're talking about a lot of data. So are you actually connecting that system to a backend so that you have analytics run on cloud machines or data centers to really get advantage of the compute and storage you can get up there, right? So you basically that solution is connected to the cloud.
Yeah, it is connected, but it we cannot just upload all this amount of data in the cloud. We're talking about terabytes of data every day generated by those scans. So we have to use edge computing to reduce this data to to do the first pre-processing on site and push onto the cloud just the results, the output of the algorithm. So and that's the key of delivering results in 24 hours. And it's also solved one of the big problems happening in the mining industry right now is the tremendous amount of data that is generated by all those new sensors coming into operation, and it's really flooding the mining industry with those new data sets. And well, the industry is not ready to, well, just take and absorb this huge amount of data in terms of infrastructure, but also in terms of internal expertise into, well, digesting and processing and getting the value from this data. So it's why we do the edge computing and deliver, well, what is actionable for the customers. Well,
Yeah,
of
yeah.
course, they can have all the raw data if they want, but we just know that no one is ready to digest. They want
It's
to make decisions. So
Yeah, it's a lot of Excel spreadsheets, I guess,
yeah,
that people use. But like we're kidding about that, but that's the way many people have been doing analytics, especially in domains as specialized as this one, right? The geologists need to have a lot of data to extract actual information, and they have tools like spreadsheets in order to deal with that. So now they have computers already, so it's not everything manual, but being able to leverage algorithms that will run at the edge, we were saying, to filter part of that data, they can really work on the part of the data that they're interested in to, as we were saying, get results rapidly. There is also, I would assume, some level of machine learning that is used, both in the cloud once the data has been sent, as well as on the machine at the edge. So if you have software running down there, you have communication with backend in the cloud. So you need an IoT solution. You need something that securely connects the data or these installations, these edge machine to the cloud. And this is a domain that, and we'll talk about that a little in that third part of the conversation, which is about the challenges you've encountered. But before we get there, I'm curious to know how much of IoT there is in that story, right, of your solution.
and yes, there's a big part for IoT. And now we were talking about one unit. So let's imagine we have tens of those units in the field everywhere in the world. We have to maintain the location, the health report of all these equipment, the, well, monitor the analytics, and so we have to remotely connect to those equipment to monitor, because our work is not only to scan data, it's to QA/QC and to do the final delivery to the customer. So we have to constantly log in into those machines, verify that they are processing data accurately. We have to, well, support operation people in the field remotely. So it's where IoT have a great advantage for us, that having this connection from remote to local equipment, going from the cloud, in situation that, well, connectivity is most of the time intermittent or low bandwidth. So we have to, well, have that pipe to monitor
Got it.
the units.
Got it. So remote monitoring, checking that all the device, the health of the equipment and installation, basically being able to support intermittent connection and connectivity. Yeah, mining thing can definitely be tricky there because you're in a remote location, and you need to make sure everything works because you want to guarantee that 24 hours.
Yeah.
For making the decision. If the system was like just not working somewhere remote, you can have all the technology you want. It will not help much. So, Simon, tell me a little bit about the few challenges. One of the, you already talked a little bit about a first one, that is the fact that there is a lot of data that is being generated with a new generation of equipment and machines in the world of mining. So it's great to have a lot of sensors. It's great to have automation, but that's a lot of data. So tell me a bit more about, the realization that, wow, we need to first, gather all that data, but we need to extract insights as well.
Yes, absolutely. Well, before we started LithologIQ, we were discussing with the mining industry for about 2 years and trying to pinpoint the main challenge related to mineralogy, of course. And one of them was too much data and too few insights. So we craft our solution to just reverse this problematic and to solve this problematic. And it's why we design advanced processing just to do a basic, well, it's not basic, but it's really a huge pass of data reduction.
Mhm.
It's not compressing, it's not just filtering, it's really extracting insights to give actionable data to the customer. They want to make decision based on not hyperspectral data, but mineralogical data and other insights we can generate. So earlier you were asking about AI further analysis. So that's where AI take parts in our solution. So we just extract and generate synthetic indexes about key parameters that are relevant for the mining activities. If it's operation or exploration, we can generate the indexes that really helps geologists or technician or drilling just to make a quick decision. That this really reduce the data they have to have in hand to make that decision.
Yeah, makes sense. And another aspect related to that is the infrastructures, right? So it's one thing to bring a
Mhm.
new set of sensors and new equipment, but you're still in a remote location, connected over satellite, maybe cellular. But like the infrastructure and the networking one in particular is just not fit by default, right? There's work that needs to happen there.
Yes, that's another challenge indeed. We cannot rely on stable and IT, connectivity to the cloud infrastructure. So it's why we made our computation on board with edge computing. But still,
Mhm.
we have to distribute the results among the local core shack or to the remote geologists that work remotely at home or in a different town who want to monitor the activity ongoing on the site. So, there are technical solutions for this today, of course, satellites, connection, and etc. But the key is always data reduction to assume that we will have the smallest pipe possible and potentially intermittent pipe to connect to the cloud. So we distribute only lightweight results.
That
So
makes
that's one challenge for sure, the IT infrastructure, but the overall infrastructure of a core shack is quite a challenge because we have to just get inside an actual workflow of operation where people are used to do things in a certain way for years and years, and we have to shift that paradigms to bringing another sensor, another tool, just as the first step of everything that's happening. So drills, what we hope for is core scanning, then logging. So we can really leverage the quick on-time data results,
sense.
because the next step of the geologist will be to do his core logging, taking from our pre-log that we will have done in a few minutes earlier. So drill, pre-log, log, then it's where we think we can create the most value.
Nice. So talking about both value and the operators, you already like kind of mentioned that, but digital transformation is about transformation. Lots of changes arriving at once, new tooling, new technology arriving there, especially for operators. It's something that can be, unsettling. I would say they appreciate new tools. I mean, you give a someone who was working on the field a new set of tools that are like happy as Christmas, right? But technology for the sake of technology is just not working. There is a special recipe for a digital transformation to be successful. And Sim Lithologic, you figured out what to focus on in order for that digital transformation to really happen and for operators to embrace the solution. So what is that recipe? What is the secret ingredient here?
It's value. It's value creation. Every No one can be against value creation in the process, even if it requires deep transformation of the process. And the
Mhm.
challenge is that for every mine, the value creation that happens at the different places. Some people are just trying to clarify alterations because they are trying to victorize toward their mineralization as quickly as possible. Some
Mhm.
other mines in operation are more trying to solve metallurgical process problems, so they want to know as much as the mineralogy as possible from their cores, because it might explain some variation into the output of the mine, while some other mines are just trying to solve the backlog constraint, because they have not enough geologists to do the core logging work. So At every site, we have to really talk with the customer, understand what's the most painful point, what they are trying to improve. Then most of the time, there's a really well standard core in our solution that just requires some modifications
Mhm.
to provide those value, and most of the time is by adjusting the synthetics indexes we generate. So if you want to vectorize to your deposit, so we will just generate those insights that give, well, like a compass, where
Mhm.
is the best way to the best place to drill. If you're trying to solve metallurgical process, we can identify rock hardness or presence of deleterious minerals. So these are insights that will tell, hey, do
Mhm.
not extract this part, extract this domains, but mix it with the other domains next to it. So this is really insights that solve actual problems.
Got it. So focus on the actual outcome for the users, for the customer, for the operator. That what will make it work. You just mentioned a couple of very interesting things that will lead me to the last question I have for you, which is, well, edge compute has to be adapted, changed, right? Because customer might not have all the same needs, and so you need to adapt what's running down there to extract the right insights for them. So that's one part, which is, software at the edge is something that is complex in its own, on its own. The connectivity as well is complex because you need to remotely eventually deploy new machine learning algorithms or configuration for this edge compute. So not trivial. This is a domain that is very specific that we call IoT, embedded development and IoT together, that you might not have been an expert at Lithologic. The other thing you mentioned, really interesting, which is you need to engage with the customers, with the geologists. It's a different world. It's something where, you might be an expert in the cameras technology, in the algorithms to extract the right data, but it's their domain, right? And so we're starting to see different skill sets, different personas having to work together to have the value you were mentioning, out of a solution. So tell me a bit more about this challenge of, the shock of the cultures of these different domains.
Oh, you mentioned a lot of different technologies and domains in that, and you're absolutely right. IoT, AI, cloud computing, remote connectivity. It's all different expertise that we cannot master all at once. I mean, we are experts. We are really strong experts in a very narrow field of expertise, right? I think it's becoming the case of many different industries, because technology is becoming so much more complex than it was 10 or 20 years ago. So we cannot have an expert of all of these internally. It just make no sense in economically or logistically to hire those people. First, those experts are mostly quite expensive. They have a very narrow expertise, an expertise that we absolutely require. But for about, 6 months, a year maybe, and maybe a few hours per year to maintain the solution. So those experts would be bored if we were to hire them at Lithologic, because the challenge is very, very high up front, but lowers as much as the solution is deployed. So what we did in this area, our solution was to hire external experts like Axceta, who
Mhm.
brought a lot of expertise in IoT and cloud, in edge computing, just to bring that very high level expertise early upfront in the project from the starting phase. So we got them pretty soon as the project was started, just to craft, to architecture that solution with
Mhm.
us, to bring their expertise up front, to do a lot of work in the first 6 months, and maintain the solution with us. Up to now, I would say I don't read the future, but I would say those kind of expertise has to be maintain a few hours just to maintain the solution over the years.
Mhm.
But it made no sense to just try to develop those expertise internally. So
Yeah.
that's the way we found to have the highest technological solution at the lowest cost.
I think we're observing the same thing on our side at Axceta. The fact that we are experts in a domain of IoT, connectivity to the cloud, cloud compute, edge compute, and others. But yes, we do recognize the fact we will not go and create the lithologic solution ourselves, right? You will. But we will definitely help on all these aspects of the technology that are hard to grasp and understand. And you could learn, you could hire, but then it would
Yeah,
put you out months away, more expensive on your side. So I guess this is good complementarity here that is required by the fact that we are at that digital transformation step of the industry, and it's not going to change. There's going to be more and more collaboration, more and more need for these interactions between different domains of expertise, and we like to believe at Axceta that we can be one of the parts of this cog machine. We can be the glue between some of these technologies, and allowing you to add the value you were mentioning a second ago.
it's all about time to market, right? So, what were our other solutions to get those expertise inside it? It would have taken months just to raise that expertise level internally. It's just nonsense. So, working with Axceta brought us, well, 5 people next week, just with eye expertise, really focus on what we had to do. So it was a great value added for a solution. So we saved
Great.
months. Absolutely.
Well, we like to hear that. Simon, thanks a lot for your time today. We learned a lot about mining and how things are done, and we'll learn about lithologic solution as well. So thanks for your time, everyone. Thanks for tuning in as well. See you.
It was a pleasure, Oliver. Thanks for the invitation. Bye bye.